Tuesday? Okay, Tuesday, 2 to 4. All right, so the final exam's Tuesday, 2 to 4. A couple of things I forgot to, and I think somewhere else in my slide set I might have this word, but regenerative agriculture. Um, I'm sure you've heard of the term sustainable agriculture, but do you know what regenerative is trying to get at? At least from my perspective, when I hear that word, I tend to think of it as almost one step above sustainable in the sense of the extra effort, because with you're trying to regenerate. So you're trying to leave it better than you found it type thing is usually what we mean by that word. Whereas sustainable, you're like there's a lot of connotations to sustainable, but I don't know. When I hear someone talk about regenerative, it's like they're taking it up a notch from sustainable and like, let's make it even better than it was, than we found it. So I just wanted to point that out. And then the other thing too, with apparently, I don't, where did it go? The word, Jord, I was saying Jord, apparently it's Yord. I didn't know that, but and it was a total fluke. The other day, I heard the words of someone saying it verbally. I'm like, wait, what? And then I looked it up and apparently it is Yord, not Jord. So my bad on that one. So let's see. So we talked about Yord Biosciences and how they are um, focusing on the correct cocktails or suite or mixture of microbes for your particular issue. And then I think we were looking at Pivot Bio was another one we were looking at, where they are looking at reawakening the microbes in the soil that can fix nitrogen and kind of forcing them to do that under the right selective pressures here. And so they are looking at, these aren't plants that form nodules and like legume plants do, where the bacteria are in the nodule and doing all that. They're more thinking about the bacteria that live free living in the soil and on the root, and that if they can tweak it correctly, they can get those bacteria to wake up that gene expression for nitrogen fixation processes and have them fix the nitrogen. And then not only did they do that through this work, but they're also getting the bacteria to excrete out the fixed nitrogen to the roots at a higher rate than typical. So they were doing a little extra work on that just to make sure that the microbes weren't keeping all the nitrogen to themselves. They did excrete it out. So we looked at that with this paper that they published. I'm just giving kind of the synopsis for you to read through on the big picture idea there. And then we looked at this figure where on the left is like what we, generally what we're currently doing, and on the right image is what they have done. And of course, a lot of this work is done with, the big crops like corn or wheat, things like that, where it's a big deal. Oh, I wanted to show you just a visual. Let's see. I'm going to do that. And let me show you a visual, a short little video clip. It's short and sweet. Corn, get it? Sweet. I'm tired. All right. How do I do this?
Here's how Pivot Bio microbes work. Our microbial products capture nitrogen from the air, convert it to a form for plants to use, and provide nitrogen fertilizer directly to the crop all season long. This reliable source of nitrogen fertilizer is applied on seed before planting. Pivot Bio's on-seed application has been verified to ensure plantability, flowability, and even emergence. In the soil, the microbes encapsulate the seed. As the seed germinates, the roots immediately establish a mutually beneficial connection with the microbes. Their role is to capture nitrogen gas from the air, convert it to ammonia, and feed it directly to the corn roots. Pivot Bio's current generation of products deliver the equivalent of 40 pounds of nitrogen fertilizer per acre. That means a seed box treated with Pivot Bio has the nitrogen equivalent of 1,200 gallons of anhydrous ammonia, or 5 tons of urea, or 1,700 gallons of UAN. Farmers can be confident with Pivot Bio as the foundation of their nitrogen program. It's a predictable source of nitrogen across all soil types. It does not wash away during weather events, nor does it volatilize into the air. It stays put, weather or not, until the job is done.
Okay, so lots of benefits in the sense of less pollution with applying the inorganic fertilizers that might not get taken up immediately by the roots, get washed down into the water table, volatilized up into the air, which makes it not useful at all to the plant and does pollute the air. And then, they were saying it doesn't wash off in the sense of when they use Pivot Bio, it's because the microbes are attached to the roots and they're doing their job. You don't, whatever the weather, whether it's, a downpour or whatever, as long as the microbes stay alive, they should be doing this. So that's their spiel on why Pivot works so well. And so it's actually a great idea, and it seems like it's working. They're getting people interested in it and have been using it. There's been some trials done. So that company has been around for a while. Here's another one, Sound Agriculture Company. This is another one that is looking at a slightly different angle. So I'm just trying to give you some, options of what are people thinking about in terms of how can we do this better. This one is interesting. So, they're saying, yep, we have quite a bit of challenges to grow enough food. We need to deal with all the issues we've created in terms of pollution and all of that. What can we do? So their idea was to study how plants talk to the microbes, or I shouldn't really say talk to the microbes, how plants and microbes are interacting. We know that plant roots excrete all kinds of chemicals. They were looking at that dynamic to see how they could manipulate the microbes to do what they wanted it to do for this company, which is they were focusing on microbes that can solubilize phosphate and also deal with nitrogen fixing and feeding all of that to the plant. They decided, so here this is a PowerPoint slide from one of their slide decks that they use for advertising. The soil holds the power, science sets it free. So they're saying they're mimicking what the plants are naturally doing with the microbes in terms of the chemical interactions that are going on to get the microbes to start solubilizing phosphate and fixing nitrogen. And we're going to watch a short video on this as well. But basically, they're saying they turned it into chemistry so that they can apply their product, which is called Sound, I think, is what they refer to it. Or no, I'm sorry, Source is the actual product. It's the Sound Agricultural Company. Source is the name of their product. And so it is something that you can apply in a foliar spray. So that's another huge thing about the idea of how can we do this better? You have to make it practical so the growers can easily implement it into their practices. So if you find something, but you can't, you have to develop a whole new piece of equipment, or if you make it too complicated for the growers, they probably won't buy it. And so you have to always think about the application. How do we do this? So it's easy for the user to actually buy our product and get it into action. Easy to use, low rate and flexible application window, foliar spray compatible with most tank mixtures. You don't have to use much. You can add it at different parts of the growth cycle. They're claiming that they can get increased yield and a positive return on investment. So let me just show you the short video on this.
Welcome to the rhizosphere.
This is an
The
interesting
soil
video.
surrounds the root
Kind of
zone.
weird.
Here, soil is populated with billions of beneficial microbes. You can see some now. The reality is that lots of nitrogen, phosphorus, and micronutrients already exist in the soil. The problem is that these nutrients aren't available in a form that plants can use. That's where microbes come in. What you're seeing now are nitrogen-fixing bacteria and phosphorus solubilizing microbes. They're busy taking nitrogen gas and phosphorus from the soil and turning them into forms the plants can use. But the microbes don't do this for free. In return, the plants give the microbes the sugar they need to survive. Today, plants get most of their nutrients from synthetic fertilizer. You can see it now entering into the soil from above. An unintended consequence is that fertilizer limits the important interaction between plants and microbes. This causes microbes to go dormant, which can be a problem when plants run out of fertilizer due to leaching, tie-up, or other issues.
Okay, so that's an important concept right there. So when the farmers are fertilizing their fields, so that you're applying a selective pressure, so you're giving a lot of nitrogen and phosphorus to the plant. So then essentially the microbes in the soil, you won't have this interaction between the plant and the microbe because of that, all that fertilizer. The microbe is just going to be like, I don't need to solubilize phosphorus when I'm getting it for free. It's raining down on me. I'm just going to eat that. Same with the nitrogen. And so the microbes go dormant. And so the farmers are actually putting a selective pressure that it's an unintended consequence. So for decades, they've been doing this to soils, and the microbes in the soils are like, well, I'm not going to go through all the trouble if it's just raining all these nutrients on me. And so now they're saying if we at least reduce how much of the fertilizer we use, reduce that selective pressure so it's not so constant and abundant, then those dormant microbes should wake up. If we add in this case, it's the what is it? I keep the chemicals, foliar spray. I keep mixing up their name with the product name. But anyways, all right, let's listen.
When plants run out of fertilizer due to leaching, tie-up, or other issues, creating deficiencies. This is where source comes in. Source mimics the plant signal that activates microbes. When the microbes detect source, they start transforming nitrogen and phosphorus into plant-available forms. Source is like caffeine for the microbes, helping them work harder to provide more nutrients to plants, which in turn makes them healthier and more productive. Now let's return to a normal size and see how the crops are doing. Here you can see a source field next to a control field that was treated only with synthetic fertilizer. The source plants are greener, more robust, and taller. Underground, the roots are also larger and healthier thanks to the increased activity with the soil microbiome. Source is so effective that in most fields, you can replace 25 pounds of nitrogen and 25 pounds of phosphorus per acre without limiting yield. That pile right there is all the fertilizer this grower saved by using just 4 gallons of source. When source becomes part of your nutrient plan, you can reduce input costs, save time, and improve soil and plant vitality while avoiding the negative water and climate impacts of synthetic fertilizer.
Okay.
Welcome.
Whoops. I thought the graphics were a little interesting, but I guess they got the point across. All right. So a really good idea. So then I went digging, what is this foliar spray that mimics what the plant is doing to get those microbes up and running? And it was hard to find. which I guess I'm not terribly surprised. Because it's probably, in fact, I had to find it in an older document. So I think they might have purged it out of some of their newer advertising. So it's in the notes section on this slide. So it says, source unlocks nutrients in the soil to be used by the plant using groundbreaking science to mimic natural plant to microbe signals that initiate atmospheric nitrogen fixation and phosphate solubilization nutrient cycling functions. Ultimately, source leads to increased yield. They've done 60 trials in 2019. So they're saying, yep, we got a good yield. And then it says source uses a new active ingredient called maltolactone developed in-house. Simply, it's science that stimulates the microbes already there to manufacture nitrogen and phosphorus fertilizer at the root zone. We can get these microbes to work a lot harder. So maltolactone. So maltol is a sugar alcohol. And lactone, I thought that was interesting because when bacteria talk to each other, many bacteria use homoserine lactone as a chemical communication system. And so they're using maltolactone. And so, as I said, I had to find this in a 2019 document, and I couldn't find it in the most recent ones. So anyways, I think that's primarily what the chemical is that they're saying, do that as a foliar spray. And then the plants will excrete that out to the bacteria to get them going and help them get access to phosphorus and nitrogen. So kind of mimicking, it is a way to communicate for the plant to communicate to the microbes and tell them basically get going on your job of getting me access to phosphorus and nitrogen. So I thought that was an interesting way to go at this problem, but they're all kind of coming up with different ideas, different approaches, but a lot of the same similar consequences where you can reduce fertilizer pollution and have it more sustainable over time to the, so the plant is getting fed over time in a more even way. So a lot of this stuff that they're doing right now is synthetic biology. Does that sound familiar to anyone? Synthetic biology? It's a new thing, relatively new. It's really taking off. This is a whole field of study that now with our technology, it's really taking off. So you can really think of it as the engineering of biology. So you are seriously tinkering with microbes, often are used, sometimes plants. Microbes seem to be the favorite tool, but you can really alter or even introduce a new physiological pathway through synthetic biology. And it is amazing what they are accomplishing. I was trying to get out to the conference last year. It's always held once a year. I think it's once a year in San Jose, California. They have a SynBio conference. So I looked at the cost to get in, and just to get in, it was over $1,000 just to get in. And there's no way I can afford that with what we get here for going to conferences. I would be in debt. And so I couldn't go, but maybe if I save up enough, I can save up my professional development. Maybe one of these years I'll get to go. But anyways, really interesting things that they're doing right now. And this is taken from what's synthetic biology into right now and how can you apply it. And so you can see that there are a lot of aspects that go into it. It's very interdisciplinary, extremely interdisciplinary. As the left image is trying to show, and then the right image is trying to show, what's it good for? What are they working on? And so you can see there's all kinds of ideas here, including looking at agriculture and improving that in a sustainable way. So I think, as you go out and live your life in the next few years, you're going to hear more and more about synthetic biology. I'm sure you've already heard about biotechnology, and it's just kind of like biotechnology on steroids. It's ramping up, and really with our technology being able to seriously either fully synthesize new pathways or heavily tinker with ones already in the works. And so this whole idea of can we use synthetic biology for the future of agriculture, definitely. They are really starting to think about that. And it's exciting to see all the different ideas that are out there right now. One idea I did want to mention, although this is not exactly plants in agriculture in the sense of, well, it is, but it's focusing on people who eat meat as the end user, right? And so the Impossible Whopper, I'm sure you probably are familiar with that, and it's still something you can purchase at Burger King. And at the last plant biology conference I went to, the owner of the company who developed this gave a whole session on how did they do this, why did they do this, and basically all the farmland that we're using for cattle production is extensive. And you think about the cattle contributing also, to greenhouse gas, although it's not the cattle directly, it's the microbes inside them that are causing the greenhouse gas. But anyways, farming for meat is most destructive on our environment. The amount of water you have to use, the greenhouse gases, the land use, and the destruction of forests that are going on in more of the tropical areas is astounding. And it's so sad because once those forests are clear cutted and they graze cattle on it for a while, it's only good for about a year or two. And then the soil just goes to ruin. They haven't found a way to like really regenerate that unless someone else knows something I'm not aware of. But it's a very non-sustainable way of raising cattle. All kinds of pollutants, of course, are coming off of this practice, and also deadly microbes that if you don't cook the hamburger meat or whatever correctly, you can get very sick from contaminated microbes that were in the intestinal tract of the animal before slaughter, and then it got into the meat during the processing of the meat. And of course, the reduction in diversity is also an issue. So what they're saying is that when they do this, Impossible Whopper, when they get it's all plant-based. So when they're growing their plants, they're saying we use 1/10 the amount of water, land, and fertilizer than if you were raising cattle. And they're doing it through plants. So Dan Brown, he's really was a microbiologist. So he has a lot of expertise with microbes. So part of this, he was looking at microbes for this, but basically he talked about in the conference, like how do we mimic the taste of meat, and not just the taste, but the mouthfeel. We have a very defined palate on what we consider to be meat-based. And if you taste some of the other fake meat hamburger patties, for example, very often you can tell right away this is not meat. And so they would have focus groups that, they go through these formulations and then they'd have people taste it. And they went through many iterations of this over time. And they said, basically, we have to trick them into saying, yeah, this tastes just like meat, even though it's not. And what they finally hit upon was you have to provide that heme flavor, which hemoglobin, heme, blood. And so that very trace amount of blood and heme in the meat, when we taste that, that's our brain, it goes to our brain that, yes, this is meat. And so that was the crux of the matter. And so heme in the blood makes meat taste like meat to humans anyways. That's how we go around it. So this is the so-called umami flavor of beef with that heme. So he said, okay, well, how can we do that and still be plant-based? And so he knew that, so myoglobin is what we have in our blood, but leg hemoglobin is very similar. And we've talked about leg hemoglobin because this is what is produced by the plant when the plant and the nitrogen fixing bacteria start to partner up. And so he remembered that, oh yeah, when bacteria, I gotta alter that, it's not prokaryotic only anymore. There are algae that can do this now with the nitroplast organelle. But when you think about this leg hemoglobin, it's bacteria that are hanging out with the plant, and it's that dinitrogenase enzyme. The reason the plant is making leg hemoglobin is that enzyme so sensitive to oxygen that the leg hemoglobin will bind the oxygen and control the release of it so that this enzyme doesn't get hit with too much oxygen, doesn't break down. So he knew all of this, being a microbiologist, and he said, you know what? We could do that for the umami flavor. We could isolate leg hemoglobin because when you look, so remember we've talked about this where the nodules are forming and that the bacteria are in there, the plant's producing leg hemoglobin in there, and when you look at the similarity between hemoglobin, myoglobin, leg hemoglobin, so similar, and that if they could add in leg hemoglobin into their mixture, they should be able to get that umami flavor. I see this needs to be edited too. They now know the whole leg hemoglobin is made by plants. They thought the bacteria did some of it, but it's all by plants. But that's not the main point that I want to get across. It's this leg hemoglobin idea. So they knew those were in the nodules. And then they're like, well, how do we don't really want to grow a whole field of soybeans and dig up the nodules. That seems rather wasteful to get access to the leg hemoglobin. So they didn't want to do that. So instead, they turned to yeast. So being a microbiologist, he's like, hey, I got a fix for that. Let's use yeast and get them to make the leg hemoglobin. And that's what they did. So they tinkered with the yeast. They use Apicea genus, and they were, it's already a well-studied yeast. So they were pretty confident this would work. And basically they got it to start manufacturing leg hemoglobin. And so that's much easier and much more sustainable than, growing soybeans in acres and acres of field and digging them up and isolating the leg hemoglobin from the nodules. That's just not practical or sustainable. So really interesting case study on how they're approaching this idea of how do we be more sustainable and yet give people the taste that they're, some people want, which is the taste of meat. And so when you look at their process, it is all plant-based. In the soybean protein is added in. They have the leg hemoglobin that's being produced by the yeast. There's potato protein mixed in, and coconut and sunflower for the oils or fats so that it sizzles. Sounds like meat on the grill, I guess. And that's important too, especially if you are cooking that up yourself. So this is another approach where they're really coming from a different angle in the sense of let's use synthetic biology and get some microbes to work for us to get all the ingredients that people seem to like. So getting less acreage involved with cattle production, reducing that is one goal that they say could help with being more sustainable. And so this is addressing that idea. Whether or not people will go for it, I don't know. Has anyone tasted the Impossible Whopper? I have, and I think it tastes very much like meat. So it's not something I would eat every day. I don't think it's extremely healthy in the sense of it's probably the fat content is probably up there.
Does look weird. The Impossible meat, like the fruits and stuff.
Oh, mm-hmm.
I'm sure they put like feet or something, because it does like bleed out when you cook it.
Yeah, it's partly coming from the leg hemoglobin though, because it is reddish. Yeah. I've never cooked it myself. I should try that.
It's kind of gross to me out. I'm like, I don't.
Yeah. Yeah, it's definitely an individual, based opinion on whether or not that would be something attractive, but it's a nice way of thinking of how can we, farm more sustainably, and cattle production is, it's so there's so many things that are wrong with it in terms, yeah. So this is coming down to the idea of food security, like why should we care about all this? So what? Well, the future of agriculture, we need to do things differently. And if you talk to anyone who's involved in this realm of research or their business, you walk away feeling a little bit scared, I have to say, at least I do. It is, we can't just do land-based agriculture. They call it the sun and soil method, where you just grow plants like we've been doing for 10,000 years and using soil and just keep doing it that way. It's not sustainable, at least the way we're currently doing it. And then the other idea is we just don't have enough land anymore for that. And so we got to do something else. We'll keep doing land-based agriculture, but we need to supplement essentially, and we need to do the land-based agriculture better. So some kind of depressing stats about how, they always use 2050 as kind of the marking point. They say by 2050, there's going to be close to 10 billion people on the planet, and that we will need a lot more food to feed them, and that our land use for ag is at a plateau, which means unless we do something really radical, there is no more usable land for agriculture. We've maxed it out. And now, having said that, there are areas in the world that could be used for arable land if you modify it. So for example, desert environments, they are like over near Saudi Arabia, they are growing food in the desert, but I haven't investigated the statistics on like how much water are they using, how are they doing that. But I know that they are studying that and trying to get that to happen. And there are other areas where maybe the soil is really salty, but they're working on remediating that and being able to put that into production. So there's ideas like that where they are working on it. But all in all, right now anyways, our arable land has plateaued. We can't really just easily put it into effect, oh, we'll just use that, patch of land. It's not happening. All the pollution that's been going on since, especially with the advent of fertilizers and pesticides and all of that, a lot more pollution going on. Climate change issues, that's definitely impacting how plants can grow and what kind of new stresses they'll have to deal with. And then the other idea is urban populations are going to greatly increase and sprawl. And you have all of this going on and just not enough farmland. And they're saying that food demand could surpass supply. And so you hear it phrased two different ways. Food security is one way to say it, or food insecurity if you're more pessimistic. So I chose food security. But basically, if you talk to people who are in this area, they say we need to come up with some really new ideas and start implementing them soon. And so that's, I'm trying to get you to think about this with this topic on what are some of the strategies that are currently out there that people are working on. This isn't totally plant-based because this is fungi, but I love fungi and I know a lot of you do, so I'm putting it in. And I really think this is a huge avenue that we should go down. I really do think that this is something where we use fungi for food. And this was kind of a serendipitous discovery by this company where they found a fungus out, I think by Yellowstone somewhere in the soil. And they had permits to do that. And they didn't just sneak in there and take it. They had permits to go in there and do this. And they found a fungus that they can grow using their proprietary methods into like pancake-like rolls, and on these like flat baking sheets. And they can then use that fungus for different types of food. So they'll take it like that, and then they'll process it in different ways to make different foods. So discovered in nature, crafted in Montana. So I think that's where Yellowstone is. Is that where Yellowstone is? That's terrible. I don't know. And then grown in Chicago. So they're based in Chicago. So the FY, trademark, delicious, nutritious, and sustainable protein. So this has all the essential amino acids that this fungus can produce, all of them. It's a good source of vitamins, minerals, and fiber. Breakthrough fermentation technology, which they won't tell what it is. I looked and they're very secretive. Lot less water, land, and energy to produce. So very sustainable. If you want to read a little bit more about it, it's a fusarium strain, which is interesting because there's a lot of fusarium that love to attack and kill plants. And yet this one is being used in this way. So this is, I'm really excited about this because it's really good source of all kinds of amino acids and nutrients and fiber. And, you know, the statistics they provide, how much less land and greenhouse gas and water, it's tremendous. So that they can do this all indoors and you can grow a lot of fungi on a very small blueprint, you know, square footage of building. Has anyone seen these in the store? So that's what the products, some of the products look like, the packaging. Nature's Find. So they make cream cheese out of it. Yeah, cream cheese. And then this is meatless patties, which I have not tried either of those. So, but you know, to take that pancake-like growth of fungus and then to process it in very different ways. And it's the same fungus. They're just processing it differently. So anyone tried it? No? Well, if anyone sees it anywhere, that's one problem about living in this area. It's hard to find some of this stuff. Yeah, have to go to Chicago. So, you know, career opportunities, thinking about, you know, companies like this, they're looking for scientists. But basically, you know, we're looking at vertical farming of fungi. Look at all that fungi. That's amazing. And so we're looking at this kind of idea. They wouldn't, nowhere on their website do they talk about how, you know, like details of how they grow the fungus because it's proprietary. They don't want to give that away. But it's probably something like this. But people like, you know, Robert Downey Jr. are getting into it and he's interested in another company. This one is called, well, it's At Last Food Company, which actually was just purchased or renamed or re-envisioned as My Forest Foods Company. So they started out as Atlas Food and just recently they switched and now they're called My Forest Foods. And so Ecovative is a company out in New York, I believe. And I think one of Dan, a former biology student who actually took this class several iterations ago, he got a job with Ecovative. And I think their first claim to fame was fungal packaging, you know, instead of, you know, the molded packaging that comes inside, like to protect your TV or whatever, instead of having that made out of whatever it's made out of, plant-based something, it's all fungus. And so that is one of their ideas. And they also are getting into fungus clothing and like fungal like purses or bags and it's all by how you grow them, you know, how you grow the fungus, but it can be very like cloth-like if you grow it the right way and process it the right way. So really, really interesting company. And one of their claims to fame, their newest thing is My Bacon. How about that one? Anyone seen that one? Anyone like bacon in here? No? Yes. So again, it's fungus based. They grow it. They use oyster mushrooms, coconut oil, sugar, flavor, salt. It grows in that tissue-like, pancake-like form. And they do vertical farming for this indoors. It's their patented air mycelium farming process. Again, very secretive. But they say we coax the mycelium to weave and grow into complex structures. So they're manipulating the fungus through environmental controls, creating new strains with tailored properties, environmental programming. And so they really had to get to know this fungus. It's an oyster mushroom, and really figure out how to get it to do what they want it to do. And so that's their vertical farming up on the right there. And then they get these thick, like, chunks and, this big growth of the mycelium in like a flat form like that, harvest it. And then they chunk it into bacon slices, so to speak, dunk it in brine, get that saltiness. Coconut oil with, get it nice and crispy when you cook it. And then the packaging, that's how you would see it in the store, my bacon. So I know a lot of people who love bacon. So I Googled that one, my bacon near me. Apparently the Taddock's Marketplace Foods, they claim, I haven't gone there yet. I didn't get a chance to go there before today, but I'm like, they claim they have it, which I don't remember ever seeing it there, but I don't shop there a ton. But I'm gonna go look for it. I'll let you know if it's really there or not. Because I think this would be interesting for taste comparison. But again, they're saying let's get rid of farming all the pigs, and it's so much easier to do the fungus and so much more sustainable. So there's a kind of like, there's an article. I think most of us know, like, bacon's not very good for you, the typical bacon, right? It's not very healthy. And red meat is now being labeled as a carcinogen for our health, so cancer causing. I've been trying to argue this with my oldest son. Haven't quite convinced him yet, but anyways, the idea that, there's an article out there with the title, "What's good for our health is good for our planet." And so they're basically saying if you don't eat red meat and stuff like bacon, that's really good for your health to cut that stuff out. And it's also better for our environment. And so it was a nice study that was done by a very well-known plant biologist, Dr. Tillman. If you're interested, I can post it if you want to read about it. It's not something I'll ask you about, but it's a good read. And they make a convincing argument that we should cut back on animal production. Ingredients: total fat, 3 grams. That's not what normal bacon is. So, and look at those statistics. That's pretty awesome. So at my next family get together, my older brother loves bacon and his son. So I'm thinking I'll sneak some of this in and see what they think, if they can tell the difference. Okay. So this one, okay, I have to admit, this is not plant-based, but I couldn't help myself. This is a really cool idea for the future of ag. This is a group in Finland that literally is making food out of thin air. That's not an exaggeration. So it sounds really weird. I watched several videos about this and read all kinds of documents on what are they doing here. But of course, they're being driven by some of the same ideas that we were talking about. How do we reduce greenhouse gas? How do we deal with carbon dioxide levels rising, methane levels, nitrous oxide, all of that? You have all the damage going on to our environment. So they're using a new bacterial source of protein. So basically, they're getting a microbe to grow that produces this protein. And all they're feeding them bacteria is some CO2 from the air. Of course, it needs water and then some minerals that they'll add into the broth mixture to get the microbe to grow. And as it's growing, it produces a protein that they're calling Solein. And it's from the Solar Foods Company. So it doesn't require, arable land. It's all happening in the microbe, in the bacteria. And so this is originally in Vantaa, Finland, and they're looking at it's capable of producing as much protein daily as a 300 cow dairy farm, but within the hygienic confines of our state-of-the-art bioreactors. So it's a microbial protein. Single cell protein, that's probably something you'll see if you stay in the sciences and learn anything about synthetic biology and all that kind of stuff. Why aren't you letting me draw? Single cell protein. Oh, it won't let me draw. Nice. Okay. They're also saying this a lot. I've seen this model of, how they're growing that protein disrupts the food chain. So it's disruptive technology. I've been hearing that phrase a lot. Which is a good thing. That's a good, it does sounds kind of negative, but that's actually kind of their new way to say we have something so cool. We're disrupting, how we normally do it. We're so good. And so they're saying it can happen anywhere. It's because it's all indoors in a big reactor. So they're taking air. They're using electrolyzers. They are putting in minerals. And they get the Solein. So what they're doing here is they're comparing what they're doing. Right? The Haber-Bosch process is what's currently in production. It's not what they are doing. Macronutrient profile is similar to dried soy or algae. And you get added iron and B vitamins, which are crucial. So basically what they're making these microbes do is this process that's called hydrogenotrophy. So they're feeding it hydrogen gas, and the microbes take that and strip electrons off of it. And they're using it, the microbes are doing that to get their ATP needs met, which then allows them to grow and divide and produce more of themselves. So it's a very kind of simple idea. So this is what the microbe is doing. It's taking hydrogen gas in the top left and it's stripping electrons off of it. And the end result is ATP. And if you have ATP, you have energy, you can go ahead and start increasing your population. And so they're just making the microbe do that. And then they isolate the protein from the microbes. And you can see the content here of the microbes, it's kicking out a huge amount of protein. You have carbohydrates, fats, and minerals. And it's quick. These microbes grow very quick. It doesn't take a full season for a plant to grow in the field for 3 to 4 months. We're talking hours where you can get a really high yield. And so this is just describing a little bit more about it, but just incredible yield, very sustainable. So this is a nice summary table of all the benefits. Definitely cost effective as well. You can do that, and they're saying you can do this anywhere. It doesn't have to, can be in any building in any part of the world. I watched a video on some chefs making a meal. So when they did their first launch of this, they invited really important people, like part of the World Health Organization and others, to come and taste what you can make out of this. And they had, top tier chefs working on it. And of course, they were making the food look absolutely gorgeous. And then everyone that was being interviewed was saying how great it tastes. It has kind of a nutty, buttery taste, apparently. So they were making like pesto. They're making noodles out of it and having like pesto spaghetti and ice cream. They made ice cream out of it. And what was the other one? Something egg-based, a fancy egg dish. So they're trying to show how versatile it is. They did like 5 different dishes that these people all came and tasted. And so it's pretty new, but I think you'll start to see that on the shelves eventually. It's not out yet into the mainstream, but it's going to get there. So sorry, that's not technically plant-based, but it's still sustainable egg ideas. And this is a big idea in the sustainable egg, right? This idea of indoor egg and controlled environment. We have this here at NMU. I was on the team that helped formulate and create those programs. Because when you live in this part of the world, you can't farm year round, obviously. Our growing season's really short, so we don't have great yield up here and certainly not year round. And so another avenue is to try to go indoors. And so that's the next topic I want to talk about, but let's take a break. And so what time is it now? So like 3:05, let's come back at 3:05.